Hello and good evening to everyone. I am George Daniel from LC Patras, and I am the online seminar coordinator of EESTech Challenge. Let me start with slides in order to talk to you what EESTech Challenge is and what we are doing here. On behalf of the EESTech Challenge board and online seminars team, I would like to welcome you to the first online seminar. I will be the host, and Dr. Konstantinos Pelechrinis, live from Pittsburgh of Pennsylvania, will be the lecturer today. He will introduce himself later on. This seminar is held in the context of EESTech Challenge. And as you may have heard, EESTech is organizing this challenge. But what is EESTech? EESTech is a volunteering European association that envisions all electrical engineering computer science students to reach their full potential in their academic, professional, and social lives. Okay with EESTech, but what is EESTech Challenge? EESTech Challenge is a competition that aims to create opportunities for European students to gain knowledge in the fields of electrical engineering, computer science, and develop a professional network. The focus and the topic of the competition will be chosen annually from the electrical engineering computer science field. This year's topic, as you know, is big data. The competition consists of local rounds and one final round. Local rounds will be implemented during March, and the 24 local committees that will organize them are, as you can see in the slide, are Ankara, Antwerp, Athens, Aveiro, Belgrade, Catania, Chemnitz, Craiova, Delft, Dublin, East Sarajevo, Gliwice, Krakow, Ljubljana, Milano, Novi Sad, Patras, Sarajevo, Tampere, Tirana, Trieste, Tuzla, Xanthi, and Zurich. Winners of the local rounds will pass to the final rounds in May. The final round represents a live round. All the first winning teams of the local rounds will be competing for the winner of the competition. Final task given by the company who is going to be the sponsor. This year, the final round will be held in Novi Sad in Serbia. Some project details. The competition is addressed to students aged 18 to 26, which will be able to reach one of the cities in their country that conduct a local round, and they can participate in teams of 3. The online seminars are introduced as a free educational tool which will be used to support our goals and help students who have great ideas, motivation, and interest about the field, but don't know how to get started. We're going to provide 3 online seminars. This one on January and one on February. During the next seminars, we're going to have a presentation of the tools that are going to be used in the local tasks, like Hadoop and MapReduce. On the final seminar, we may present some good practices on how to solve the final task. In order to stay tuned, check our channels of communication and feel free to email us in case you have further questions. Dr. Pelechrinis, you start.
Thanks for the introduction, and I'm very glad to be here talking on this topic. So as George said, we are going to be talking about big data analytics, and today it's the first seminar on big data. So let me get started, and the title of my talk is an introduction to big data analytics, and we're going to see what is big data, what are the challenges, and what are actually some also big failures that you have seen. So not only the positive things, but also some things of that you need to be cautious about. So if you have any questions after the presentation, you can also email me with that. So just a brief background for me, so you know who I am. I'm from Greece. I did my undergraduate at Athens at the National Technical University. We're actually in 2004 and 3, we started the local committee of Athens. So I'm one of the founding members of EESTEC, so EESTEC is very close to me. So I'm glad I'm back so many years after to give this presentation. Once I graduated in 2006, I moved to US. I did my PhD in University of California in computer science. And then in 2010, I joined the University of Pittsburgh, where I'm still at. So today's presentation is going to introduce big data, and here are the objectives and the roadmap that I will follow in this presentation. We will basically see what are big data, why do we care about big data now, and we will see what you might have heard as the 3 V's: volume, variety, and velocity, and we will see what this exactly means. We will also talk about the challenges associated with big data. Some of them are storage, processing, and analysis. And the vast majority of this presentation will deal with applications of big data, why big data are important. But also, I think equally important is why you should be cautious when using big data, right? So what are the big failures that you have already observed in the usage of big data, and what can go wrong, and what can we do as a precaution measure? Okay, so this slide has the time series of the volume of the query of the term big data analytics from Google search engine. As you can see, 10 years back, nobody was looking for big data, but after 2010, 2011, there has been a steadily increase on the interest of people on big data analytics. Obviously, if you also search for other trends in Google search, like similar keywords, you will see a similar trend. So why do we? Why this increasing trend? And there are many cases. There are many reasons. The major of this is that there was success in early adopters. So when people started using big data before big data became a thing, the people that used it had a lot of success, so others want to replicate that. Nowadays, the technology is mature, so even though there are a lot of challenges associated, there is also a mature technology that can actually help solve some of these challenges. So there is an increased provision to collect a variety of data. So the idea is collect as many data as you can, and you will find some use later. So there is an increasing trend, an increasing interest in big data analytics, and this is not going to go away. So here is an expression that basically has been very popular the last couple of years because everyone wants to know what is big data. And when you're asking someone about big data, they give you a vague answer. Or if you ask 10 people what big data is, most probably you will get 10 different answers. So Dan Ariely from Duke University put it very nicely. Big data, he said, is like teenage sex. Everyone talks about it. Nobody really knows how to do it, but everyone thinks that everyone else is doing it. So everyone claims that they are doing it. And this is exactly what happens with big data. So everyone talks about big data. Nobody really knows what it is and what to do with big data. Everyone believes that and other companies do it, so they claim they are also doing big data. So I think that's a very clever saying that captures the reality for big data today. So what are big data, right? So what? Sorry, I missed. I skipped the slide, so it's out of order. Sorry about that. So big data. Essentially, why do we care about big data is because there are 3 major things that big data can accomplish for an organization. And this has to do with cost reduction, decision making, and new products and services. So let's start with cost reduction. The idea is that big data technologies such as Hadoop, MapReduce, and cloud-based analytics can actually bring significant cost advantages when it comes to storing large amount of data. So you are able to store a significant amount of information that you can basically analyze later and find more efficient ways of doing business. And efficient ways of doing business essentially means cost reduction for businesses. Now, big data can also help you do faster and better decision making, where basically, if you combine the ability to perform fast analysis with technologies such as Hadoop, you can analyze new sources of data, and business can really analyze information near real time and make decisions based on what knowledge they have obtained from this data. Now, big data can also help release new products and services. So people basically can coach customer needs and satisfaction based on analytics on data that they collect from customers. So they can actually passively understand what customers like, and basically companies can create new products that meet these customers' needs. So sorry, as I said, it was out of order with my slide. So the question is, what is big data really, right? As I said, big data sounds more like a buzzword, and people don't really know exactly what it is. And here we will just attempt to answer this question to the best that we can. Obviously, it is not a foolproof definition, but it's definitely a start. And one way I like to define big data is by defining what big data are not. Right. So big data are data that you can imagine being data that do not fit in a single machine, right? So you cannot get this data and store them in your desktop, in your laptop, or even a single server, and you need more specialized tool in order to analyze them. However, one thing that you need to keep in mind is that volume is not the only defining characteristic of big data. So volume obviously is what comes into our mind, right? So you have gigabyte, terabyte, petabyte of data. This is the very first thing that comes into our mind when we talk about big data. But big data doesn't have to do only with data. So they are being generated at much higher speed, even near real time, compared to traditional data, and they are heterogeneous. There is a variety. You get data from sensors, you get data from mobile devices, so there is a large variety on data as well. So here are the 3 V's that we talked about, and basically the 3 V's are volume, velocity, and variety. And essentially, when we talk about data volume, we talk about the size of the available data. And the size of the available data has been growing at an ever-increasing rate. This applies to both companies that collect data for their customers, but also individual people's data, right? So everywhere you visit online, you leave behind your online breadcrumbs, and this increases the amount of information that you have for yourself. So a text file can be a few kilobytes, a sound file is a few megabytes, and you can have movies easily stored that are in the order of gigabytes. More sources of data are also added continually. So, for example, what we mean here is that in the old days, companies were generating data internally through their employees. But now, currently, the data are not generated manually by employees, but also you passively collect them from your customers. You can have machines, such as sensors, that generate the data. So smartphones, for example, send a variety of information to the network infrastructure and to the network operator. This data didn't exist 10, 20 years ago. We also have more sources of data that we need to combine and analyze than before. This is a major issue for those that are trying to put this data into usage. Now, you don't only have to care about one source of data, but you need to care about several sources of data that can give you different angles in the same problem. So the days where we will have exabytes of data are not far away, right? And indeed, in some fields, this is a reality right now. So this creates issues with regards to how you analyze and process this data. So in the past, when you had small data that could fit in one server, you could analyze them with the batch process. You take a chunk of data, you submit the job to the server, and you wait for the result. This works when you have incoming data rate, a slow incoming data rate. So you have data that you collect offline, you analyze them, and you can do this batch processing. But as we said, one of the characteristics of the big data is the velocity, right? So you can have data that are generated at a very high speed rate, and you need to process them without delay. For example, such sources can be social and mobile application, where you generate data very fast. And in these cases, batch processing breaks down. So you need some sort of real-time distributed streaming processing. Now, data variety is the third V in this process, where basically in the past, 20 years ago, data were basically an Excel table, or in the more advanced form, it was a database. But now, these are not enough. All the data are not necessarily relational data. You can have data that range from pure text, which is unstructured data, actually, or a photo, image, audio, video, GPS data, sensor data, of course, relational database as well. So all of this, you cannot just store them in a table or in a SQL database. So you need to have specialized infrastructure to be able to deal with this heterogeneity. And as new applications are introduced, new data formats will keep coming. So this is not going to end. You will keep getting more and more variety. The big data landscape is also increasing. So there is an increasing number of companies that try to help organizations and enterprises to deal with these challenges. So you have traditional players such as Oracle and IBM, SAP, that are working in the area. You have other conglomerates like Amazon that are offering big data infrastructure as service, for example, with Amazon Web Services. Startups are also trying to get a piece of the pie, and they're specializing on specific niches of this area, such as visualization with Tableau, or access to data, where you see data as a service, where, for example, you have GNIP, which is a data, you can imagine it as a data broker that collects data from social media or other sources and then resells them to companies that want to make use of them. Or, for example, as you see here, INRIX, which is basically a company that collects a massive amount of transportation data and then sells them to the Department of Transportation or to other local governments and organizations that want to get access to this data. So the big data landscape is a vast landscape, and you can find companies that deal with technologies like Hadoop, Apache, and other technologies that provide business intelligence, like traditional ones like IBM, Microsoft, Oracle. You have the big conglomerates like Amazon and Google that provide infrastructure as a service, and then you have startups that specialize in specific niches of the market. So the challenges associated with big data are several, and clearly storage is one of them, and the first one that someone has to worry about. After all, you cannot have analytics if you cannot store them. As you said, big data cannot fit in a single machine. That's the way to define big data. Therefore, what we need is distributed technologies that can store the data over several physical devices. One problem that this causes, though, is that we need to consider things like network bottlenecks. Because now, if you have the data on separate physical devices, you will need to transfer data from device to device, and this can create a vast bottleneck for networking. The good thing is that companies nowadays do not really need to worry a lot about this infrastructure, because the big companies like Microsoft and Amazon, they actually provide this as a service to everyone that wants to use big data. So if you want to store a large amount of data and then process them, you can basically buy this service, buy servers from Amazon or Google or Microsoft or any other company that offers this infrastructure as a service. So the storage itself is not a big challenge from the perspective of an enterprise that wants to use big data, but it obviously is a big challenge from the perspective of the service provider like Amazon and Google and Microsoft that provide this as a service. So once you have solved this problem of storing the data, the next challenge that you need to face is processing and analyzing them. In the general case, as we said, we have a variety of data, and we need a new paradigm of analyzing all of this data, since simple relational SQL databases might not be appropriate for storing the data given this variety of formats. Distributed file systems are needed. There are actually new technologies that can be used to analyze and process data, such as Hadoop and MapReduce. and we can even move beyond CPU processing and go to graphical processing units, GPUs, and of course, supercomputing technologies. Now, the focus of this presentation is not the technology itself, right? You're not going to learn a lot about MapReduce and Hadoop from this presentation. My understanding is that the second or third seminar of this series will go deeper into these cases. But let's very quickly, in a few slides, try to understand the MapReduce paradigm. So we're not going to learn how to program in MapReduce, but let's see what is the paradigm in order to see the difference with traditional programming, let's say. So this figure here is just an illustrative example of how MapReduce works, which is essentially a divide and conquer strategy. Essentially a complicated task that you have to solve, you break it down into smaller tasks. Then these tasks are being solved individually by several workers. So this breaking down is what is the mapping phase. And then every worker solves this problem, reduces the problem into the individual pieces, and then you combine these pieces together to the final result. So this will be more clear with the example that we will see later, but the main idea of MapReduce essentially is to divide the problem and solve the smaller problems and combine the solutions. So the two phases that we discussed in the terminology of MapReduce are called, obviously, map and reduce. So the map phase essentially gets the input files, the input data, and essentially it creates a hash table, a dictionary, a key value pair, essentially. Whereas the reduce phase combines, aggregates these individual dictionaries and provides the final answer. So for example, let's assume that we have a task of finding the frequency of words in a big file, right? The simplest way, if we don't want to use MapReduce, is scan the file sequentially, count the occurrence of each word, and then at the end, when you scan the whole file, you have the answer. This obviously will give you the answer, but it will take forever, especially if the file is huge. So in this case, the way that MapReduce would solve this problem is that you will split the file into smaller chunks. These smaller chunks will be assigned to different workers. And these workers essentially will take each one of these smaller chunks and will create the mapping, which is dictionaries, basically. So for example, we have this input file, deer, bear, river, car, river, deer, car, bear. And then what we do is split this into three parts and we assign it to three workers. So for example, the first worker gets one part of the file, which is the deer, bear, and river. So what the mapping phase does is that it creates dictionaries. And essentially what, in this case, the dictionary is, that says the first worker essentially identified three dictionaries. Deer, which is the key value, and the key and the value is 1, because it was one occurrence. Then bear, the word bear creates another key value pair. The key is bear and the value is 1 occurrence for the word bear, and so on. Then at the end, once the workers have done this mapping, there is a shuffling process that happens where basically the key value pairs with the same key, they are all being assigned to a specific server. So for example, you see in the shuffling process that all the key value pairs with the word bear go to the first processor. All the key value pairs with key equal to car go to the second one, and so on. And then you essentially aggregate and reduce this to specific dictionaries. So at the end, the final result is that the word bear appeared twice, the word car appeared 3 times, the word deer appeared 2 times, and the word river appeared 2 times. So obviously, this might look like not providing a very big advantage over sequential processing. But I would urge you to go on this webpage at GitHub, try this library, the mincemeat.py, which essentially is an emulation of MapReduce on Python. So what this library does is that it uses the cores of your machine as individual workers, and you can actually write actual MapReduce code that is being run, emulated on your machine. And you will see tremendous speed up on this simple word counting example. So if you try and use the word counting example using this MapReduce emulation, you will see tremendous speed up compared to a typical traditional sequential processing of the file. So this is actually a nice tool to play around and get familiar with MapReduce. Now, an interesting thing to keep in mind is that computer scientists have always been trying to find ways to store, retrieve, and process data more efficiently. So the objective itself for big data is not something new. What is new is the nature of the data. The nature of the data is different, so we don't have only one type of data, relational data, but we have vast amounts of data of different types and velocity. So the challenge itself and the objective is not something new. Computer scientists always cared about scalability, right? Big O notations, they always want to find efficient ways to store and retrieve data, so this is not something new. What is new is that the techniques that we used to have to do that are not anymore as good, let's say, right? Because we don't only have big amount of data, but we also large amounts of data, but we also have large variety and large speeds of data. So now that we know a little bit about the challenges and some of the technological paradigms for big data and what are the way to solve them, let's move to the main part of this presentation, which is basically applications of big data, right? And why big data have become an integral part of technology companies. So big data have seen tremendous use, have improved operation in a variety of fields. And today we will see applications in retail, healthcare, transportation, and sports. So let's start with retail applications. Retail applications have been using data actually for many, many years. It's not something new. But big data have facilitated several operations and services in this domain during the past decade. So, for example, it helps you learn your customer. Customer behavior and the sentiment can be determined using big data analytics, and this data can actually come through interactions of the customer within the store, through direct mail, other marketing channels like social media. You can find the sentiment of your customers through the social media. You can correlate data with transaction data, online browsing behavior if you have online presence, in-store shopping threads, what product preferences, what customers prefer, and many more other things. You can also incorporate external data streams. As I said, social media traffic, you can assess customer sentiment, behavior. So some of this data are unstructured data stream, right? It's not relational transactional data. And the insights that you get can be valuable on how you can set inventory and pricing strategies. Now, another important thing is measuring brand sentiment. So brand studies use focus groups and customer polling techniques, and this can be expensive and often are not that accurate because you can have issues with sampling and identifying the appropriate people to survey. So you can use big data analytics. You can do brand sentiment analysis and behavioral trend using things like Pinterest, Twitter, Facebook. The results are still biased, but are less biased and can be used to guide product development, advertisement, and marketing programs because they are still biased in terms of who has access to this service and who is using the services, but this can represent a large amount of your customer base. You can actually customize promotions. Big data analytics can be used to create custom offers based on the browsing history that you have, based on what you bought from the physical retail store. You can customize the promotions for localized marketing. You can push coupons and offers to smartphones based on your location. You can have real-time offers via social media. Or we'll see actually some very interesting examples on that in a while. You can improve the store layout, right? Big data can be used to analyze how customers move in space inside your store. You can have sensor data, RFID and QR codes, or Bluetooth today. You can track in-store traffic, shopping habits. This can help you understand which products to put nearby. Other technologies are emerging for in-store mapping for applications such as instant coupons, and you can, in general, know the store flow. You can optimize your e-commerce if you have an online presence, which most of the retailers do have today. Clickstream data, monitoring online behavior can help you optimize the e-commerce website. If you don't have access to big data, the sheer volume of clickstream data would be difficult to analyze. So if you are not able to collect context information and click-through data, it will be difficult to do any sort of analysis. If you have this information, you can incorporate other metrics such as social media, purchase history, and improve overall your e-commerce website. You can also do order management. So big data can be very valuable for inventory management and tracking. For example, big data can help inventory needs in order to facilitate real-time delivery, and this is a big issue today, a big challenge today for companies like Amazon. They want to have very fast and real-time, almost real-time delivery. And you can use to automate order processing such as out-of-stock goods, right? So you can provide services where basically you have a better order management. All of those are important to retail companies, and they are important enough actually to build research laboratories, such as the ones that Google, Microsoft, and Facebook has. So it might be strange, but Target and Walmart, they both have significant research labs that hire CS and engineering PhD graduates to help them solve all of these problems. And this is actually a very good indication that big data are of extreme interest to them. So let's see some specific examples here. So we talked about Target having the research lab, and actually Target has one of the most well-known big data success stories. So one of the stories from Target that made big headlines is that they were able to correlate a baby shower registry with guest ID programs, and the retailer was able to identify other products that pregnant women were most likely to purchase. And then they could customize basically promotions and coupons to these products. So this registry tracks data such as purchase history, returns, web visits, whether you have contacted the customer support, other web clicks. So Target was able to actually target pregnant women with special offers such as offering coupons for prenatal vitamins, moisturizing lotion, and so on. The same strategy is being applied to other shoppers using age, education, marital status, and more. So they are able to correlate large amounts of data and are able to offer personalized coupons. Now, another interesting story was from a pizza franchise chain store, where a pizza chain offers customers a mobile phone app for mobile marketing and deliver special offers. So what this Papa Murphy's pizza chain did was that they matched app user data with local weather conditions. And the pizza maker was able to offer special delivery coupons to customers that were unable to cook because of power outages during a storm. So the mobile, this program actually yielded a 20% response rate, which is very, very big. Actually, there was a study that was performed by GrabHub, which is a startup that basically facilitates home delivery, food home delivery. That they found that when actually there is a storm, pizza deliveries are increased, and not only that, the tip amount that people are tipping the delivery boy is increased as well. Now, Kohl's, which is a big box retailer in the US, is testing real-time offers in its stores for shoppers who opt to offers delivered via smartphone. So if you allow calls to send you coupons through a smartphone, you can get more personalized coupons. So for example, if shoppers visit the shoe department, the app can correlate this shopping and browsing history that they had either in-store or through the website, and deliver instant coupons for shoes that these customers viewed online. So the healthcare industry is also another big industry that has relied on big data during the past decade. And actually, maybe more than any other industry, is on the brink of a major transformation through the use of advanced analytics and big data technologies. And there are 4 major trends in healthcare nowadays. So the first one is the healthcare IoT, where IoT stands for the Internet of Things. So there is a rapid increase in the numbers of smart and connected devices, such as sensors, that generate and exchange data about people and the environment. So the spending actually on healthcare IoT is about $120 billion by some estimates. Most of this data are created in an unstructured way, and you need big data technology such as Hadoop in order to basically analyze this data. So what do these data provide? They provide a variety of monitor devices, monitor every sort of patient behavior: the glucose level, fetal monitors, electrocardiograms, blood pressure. So all of these are devices that generate data at a high rate. Many of these measurements require a follow-up visit with a physician. So you take your measurements, your blood pressure, your glucose level, and many of these will require follow-up visits. But if you do smarter monitoring, these devices can communicate with other patient devices and greatly refine this process. So basically, you can learn whether other patients in the same with similar measurements, similar characteristics like you, whether they actually had a follow-up visit and what this follow-up visit said. So you can replace this follow-up visit maybe with a phone call from a nurse, and this can significantly reduce the cost of healthcare, not only for each individual, but for the country as a whole. Other smart devices, they are detecting whether medicines are being taken regularly at home. If not, they can initiate a call to their healthcare provider to make sure that patients are properly medicated. So the possibilities that are offered by the healthcare IoT is basically to lower the cost and improve the patient's healthcare. Now, the other big area where big data analytics are used in healthcare is reducing fraud, waste, and abuse. So the cost of this fraud in the healthcare industry is a very key contributor to the spiraling healthcare costs in the US. So big data analytics can actually be a game changer for detecting healthcare fraud. So basically, predictive analytics are being used by the Centers for Medicare and Medicaid Services. They prevented more than $210 million last year from fraudulent claims. So United Healthcare, for example, transitioned to a predictive modeling environment in order to identify inaccurate claims. So there are patterns in inaccurate claims, and United Healthcare was able to use big data technologies to basically detect this, and generated an almost 2,000% return on their big data technology. So the gain they had was tremendous compared to the investment they did on big data infrastructure and analytics. So the key in order to identify fraud is the ability to store this data and go back in history and analyze this largely unstructured data set of historical claims. So what people have claimed in the past for healthcare. So then you can use machine learning algorithms to detect these anomalies and patterns. You can analyze patient records, billing to detect anomalies. You can see whether there was an overutilization of services in short time periods. whether patients receive healthcare service from different hospitals in different locations at very close times, which you should not expect to see. So in general, you can analyze all this vast amount of data that you collect from the healthcare providers and identify fraud. The third pillar on healthcare service and how to use big data is predictive analytics, or what you might have heard as evidence-based medicine. So initiatives here basically make use of the adoption of electronic healthcare records. So the patient records are now electronic. They're actually bits on a machine. And the volume and detail of this information that you have for every patient is increasing. So there has been a big investment from the federal government stimulus of about $30 billion in these healthcare information technologies. And this was designed specifically in order to provide incentives to healthcare providers to collect these electronic health records from patients. So once you have all this information from patients, what you can see is that you can correlate treatments with outcomes. So you can combine and analyze structured and unstructured data across multiple sources and basically improve the accuracy of diagnosing patient conditions. You can match treatments with outcomes, predict which patients are at risk for a disease or for readmission. So this predictive modeling using big data is used actually for early diagnosing, is reducing mortality rates for problems such as congestive heart failures and sepsis. So in fact, congestive heart failures accounts for the most of healthcare spending. So if you diagnose this early, it can be treated. You can avoid expensive complication, but what has been found is that early manifestations of these conditions can be easily missed by physicians. But if you collect and store and analyze this vast amount of data that you have from all the patients, then you will be able to identify and detect early these conditions. So, for example, in Georgia Tech, there was a group that showcased that machine learning algorithms could look at many more factors in patient charts than doctors could. And by adding these additional features, there was a substantial increase in the ability to distinguish people who had these congestive heart failures from those that didn't. So this predictive modeling can uncover nuances and patterns that couldn't be previously uncovered. So there are actually startups like Optum Labs that have collected a lot of healthcare records, 30 million patients. They have created a database for predictive analytics tool that help doctors make informed decisions to improve patient treatments. So obviously this doesn't mean that the expertise of doctors is going away. What it just means is that it allows the doctors to simultaneously consider multiple factors that couldn't be considered before, because people do not, a human brain doesn't have the ability to process 30 million data records at the same time. So this is the promise of the evidence-based medicine. Now, the fourth pillar in the healthcare use of big data analytics has to do with real-time patient monitoring. So healthcare facilities are looking to provide more proactive care because proactive care actually is in the long term cheaper. So being proactive is better than being reactive to a condition. So you constantly want to monitor patients' vital signs. So there are monitors that do that, and you can get the data from these monitors and can be analyzed in real time, and you can send alerts to care providers so they instantly know about changes in the patient's condition. So processing real-time events with machine learning algorithms can provide physicians, doctors with insights and help them make actually decisions that will lead to effective interventions just in time. So you can have wearable sensors that give opportunity to caregivers to interact with patients in new ways. This makes healthcare not only cheaper, but also more convenient and persistent because you have it all the time. So essentially, it changes the nature of the relationship between the patient and the caregiver. So as one example, you can have remote in-home monitoring of patients with chronic pulmonary diseases. Monitors can track the weight of patients that have heart diseases. They can detect fluid retention before hospitalization is required, so you can intervene before needing to go to the hospital. And this not only helps your health, but also manages your healthcare cost. Child's asthma medication, you can track, there are monitors to track that. And in general, a wearable monitor can generate a vast amount of data that can help in real-time patient monitoring. So let's see some specific application in this area. And one of the most interesting examples is what Blue Cross Blue Shield, which is a healthcare provider in the US, has been doing during the last years. So just to give you a background, the last years in the US, there has been a huge epidemic on opioid abuse. So essentially what this means is that people are being prescribed with strong opioid painkillers, and then they're getting obviously addicted to them, and they keep wanting these opioid painkillers, and this has resulted to several overdose deaths. So data science at Blue Cross Blue Shield have started working with big data experts to tackle the problem of this opioid addiction. So what they have been doing is that they are using insurance, health insurance and pharmacy data, and they have been able to identify more than 700 risk factors that can predict with a high degree of accuracy whether someone is at risk of abusing opioids. So essentially, what, as Blue Cross Blue Shield's data scientists say, it's not one thing. So it's not like he went to the doctor a lot, right? This is not predictive. So what is predictive is a combination of things, like you hit the threshold of going to the doctor a lot, you have certain types of conditions, and you go to more than one doctor in more than one zip codes to get your prescription. So these things add up, and they have managed to identify using big data, large data sets from insurance and pharmacy data to identify which of these factors can predict opioid addiction. And then once you do that, you can reach out to people that are identified as high risk and intervene and prevent them from developing this drug issue. Another interesting example in this big data healthcare is the cancer Moonshot program. So President Obama, before the end of his last term, came up with this program, and the goal of this program was to manage to accomplish 10 years of progress towards curing cancer in half of the time. So this bold goal of the program, to basically half the amount of time needed to cure cancer, provide some recommendation, and this recommendation included big data use cases. So medical researchers can use actually large amounts of data on different treatment plans and recovery rates from cancer patients in order to find trends and treatments that have the highest rates of success. So what essentially this means is that you can collect data from all the hospitals that have provided specific treatment plans. You can also know what was the recovery rate, whether there was a remission or not, and then you can basically analyze all this data and see which treatment plans have the best chance of success. So for example, researchers have examined tumor samples in biobanks that are linked with patient treatment records. And using this data, they were able to find that certain mutations and cancer proteins interact with different treatments differently, and they could find trends that lead to better outcomes. The researchers and the doctors, they actually find unexpected benefits. For example, they find that the spiramine, which is an antidepressant, was actually had the ability to help cure certain types of lung cancer, right? And they were able to do that because they were able to analyze a unified database from many different hospitals that had all this different data. Of course, this kind of big data initiatives, they also come with other challenges, right? So, for example, you might have incompatible data systems. So different hospitals might use different systems to store their data. They might store different types of information. Even if you have structured data, the specific attributes of the data might be different. So you have some sort of compatibility issue, right? And this is a huge problem in databases that you need to solve. Obviously, when we talk about healthcare, we have privacy concerns and patient confidentiality issues. So simply put, even though there are clear applications and clear benefits that you can have, there are other things that you can that you need to consider when you're talking about applications of big data in healthcare. So another interesting example of big data analytics in the healthcare is that of Asthmapolis, which currently is known as Propellor. This started, this company, it was a startup essentially. What it does is that it produces inhalers for asthma patients that have GPS-enabled trackers. So essentially what it does is that it keeps track of your location and it keeps track of how much you use your inhaler. And then it is able to identify whether the environmental conditions around the area you are, whether they are good or bad, essentially, and can provide other users of this inhaler with information on whether they might have some asthma attack. Right? So essentially, it tries to correlate locations, usage of the inhaler, and the environment in order to provide better information to people. Actually, CDC is using this data in order to develop better treatment plans for asthmatics. So we talked about healthcare and retailers, which are obviously big users of big data. Now, the last two applications that we'll see are in some less traditional fields. And the first one is transportation. So as urban roads designed decades ago, they're now filled up with cars. So in the mid of 20th century, everyone thought that car is a savior of transportation. Obviously, today we don't think the same. So there is a big problem in many US cities and, of course, in many European and Asian cities with traffic, right? The idea is that basically, how can you use big data in order to create efficient public transport that can take some of the congestion out of the streets? And one of the things that big data can do is facilitate route design. So, for example, you can collect a vast amount of data on people mobility, and you can do that either through GPS sensors on your mobile phone, or, for example, many cars are equipped with GPS sensors. So you can identify what the transport engineers are calling origin-destination pairs. You can see where people want to go at what times of the day, and you can facilitate better and personalized route design for public transport. You can actually identify ways to reduce commute time. So an interesting experiment that happened in Minneapolis a decade ago was basically to put some traffic lights at the entrance of highways in order to better to facilitate better the incoming flow from side streets to the highway. The perceived delay was higher, but the actual commute time was smaller, and you can use big data to actually do this sort of experiments and basically identify what works best. One of the big things that we will see that people do not do well when they're using big data is they don't put human in the center of the problem. When we talk though about transportation and about our cities, humans need to be the center focus, right? So we need to basically think of humans first rather than simply reducing congestion, right? So big data can help us understand better what people are looking for into their transportation. Whether, for example, they would be interested in taking a slightly bigger route, but that makes them feel better. So their big data can actually facilitate this human-centric transportation. And of course, at the end of the day, local governments can use this big data to do data-driven policy, to basically make decisions in order to make policy decisions that improve overall the quality of living in cities. So some examples that we will see here have to do with transportation. And for example, Streetlight Data is a company, a startup company that is basically doing some analytics on electric vehicles. So it is collecting data from electric vehicle charging stations, and it tries to identify better locations for the recharging stations, dimension better these stations, so how many cars they should, how many spots for the cars they should have, what will be the needs in the future, and they are basically trying to improve the usage of electric vehicles. So basically, they are trying to make the experience of people using electric vehicles better, so as to take more people out of traditional diesel cars to electric vehicles. Of course, another big problem has to do with parking. So, for example, there is some research that has shown that about 30% of the traffic in downtown areas in US cities is traffic that is looking for parking, on-street parking. So big data can actually help in many ways. For example, one of these ways has to do with dynamic pricing of parking. So if you collect a vast amount of data on parking demand and what is the parking demand over the course of the day, you can identify a better pricing scheme so as to basically improve usage of these parking spaces. The problem in the US cities is basically that people want to park on the street, even though parking garages are pretty much the same price. So the idea is that you can increase the price in areas with small supply and provide a better experience for everyone. Actually, there are several experiments that have been done with dynamic pricing using big data that are collected through sensors, and it has shown that this has reduced congestion overall and has improved the utilization of the parking spaces. Now, other approaches here in transportation using big data is basically street design. So one of the big things in the US, in Europe things are a little bit better, obviously, in many cities, is trying to build biking infrastructure in the cities. In the US, unfortunately, there is not a lot of prior knowledge on how to build an efficient biking infrastructure. So what many cities are doing is that they are experimenting. So basically, they are creating different layouts for bike lanes, and then they are collecting all sorts of data. They're collecting data on how this infrastructure improves retail local businesses. How does it improve safety of the cyclists? How does it make them feel? How does it improve congestion, overall congestion in the street? So there is a vast amount of data that are collected, and they are analyzed, and then they can be used to basically make policy decisions on what should be the infrastructure that is built. So this is again infrastructure for electric vehicles, as we discussed earlier. And one of the things that we said has to do with human-centered transportation. So here, an interesting work that has been done by some researchers in Europe, in Cambridge and Yahoo, was basically this idea of happy maps. So what the researchers did is that they collected a vast amount of data through gaming on what makes people feel happy. So basically, they built this game, which is called Urban Gems, and basically they showed to people 2 images, and they asked them a simple question. So they showed 2 images from a city, and they asked them which one makes you feel happier, right? So collecting these answers from a very large number of participants, they were able to identify what features of the urban environment makes people feel happy. And basically, they were able to provide route recommendations for making people feel happy, rather than just making people arrive to the destination faster. So this is an example of a human-centric transportation. So finally, with regards to applications, we have sports, and this might seem strange to some people, but in reality, analytics, statistics, and data have been part of sports as early as 19th century, actually. The first box score that was ever collected, which is actually data, was collected in the 1850s for a baseball game. Now today, obviously, we have way more detailed data in sports, and some of the applications that this data can facilitate have to do with in-game strategy, right? So you can have what is similar to evidence-based medicine, but evidence-based sports strategy. You can have roster selection. So how can you identify players that provide a good value, but they are essentially undervalued in terms of money and contracts? Fan engagement. So sports is a business, and as business, they want to increase their revenue. So how can you engage your fans better? What do your fans want, both from the perspective of in-game, in-stadium experience, and out-of-stadium experience? And of course, something that is also related with medicine, how can you do injury prevention? Obviously, you cannot prevent injuries such as a player had a sprained ankle. Obviously, this is an event that is not predictable. But in sports that have repeated motion, for example, in baseball, where you have a pitcher repeating the same movement, the same motion, time and time again in the game, you can actually, people actually have analyzed the way the pitchers are doing this movement in order to see some signs of possible injury that is coming. So why all of a sudden the last 5 to 8 years sports analytics gained so much attention, and they entered this big data big data era? The answer is simple. Now we're able to collect way more information. So before 10, 15 years back, the only information that you could have for a game was basically box score information, aggregate statistics for players, for the team, and nothing very, very detailed. Actually, I remember when I was young and I was playing basketball, we were keeping these statistics by hand, right? So this was a very manually intensive way of doing things. But today, there is all sorts of technology that can generate a vast amount of data for all different kinds of sports. So for example, in soccer and in hockey, and also in basketball, obviously, you have optical tracking technology, where basically you have a set of cameras that look at that point, obviously, in the field, on the field, and they can track the players. And they can identify the location for every player, for the ball, several times every second. So this, obviously, as you can imagine, generates a vast amount of data. Now, for other sports like American football, where basically players wear a lot of padding, you can put small sensors in this padding that can capture similar information. So these sensors have GPS, and they can identify the location of players on the field. They can measure things like the speed of the player. Some sensors can actually also measure dehydration levels of the player. So there is a vast amount of information that you can get from players. And this has led to several applications, right? Maybe the thing that popularized the use of data and big data in sports analytics is the book from Mike Lewis, Moneyball. If you haven't read the book, it's a very good book, or you can watch the movie, Moneyball. So the idea is, so actually this is a real story that the book and the movie describes. And there was this small market baseball team in the US, which had a very small budget. And they were able, by using advanced analytics and big data analytics, to basically build a roster that was able to compete with much richer teams, and were actually able to have a lot of in-game success. Now, it took several years to have a major advancement in the use of big data in sports, And this came from the NBA. So the NBA has actually not necessarily mandated, but has introduced a program where all the teams, and now in their stadiums, they have 6 cameras where they track the players and the ball 25 times every second. So you have all the locations of the players throughout the game, and basically you can use this data to do a lot of analysis. So some teams, they're analyzing defensive strategies, and this small demo is something basically that was built by the Toronto Raptors, and it was one of the major successes of this technology, where basically they used a vast amount of possession data from over 2,000 games. And what they did is that they introduced the concept of ghosting. So essentially, they analyzed all these possessions and they managed to identify what is the optimal position of a defender. What should be the optimal position of a defender? By creating these ghosts, these players that should have been in specific locations, they were actually able to identify which players perform better on defense. And another application that the Toronto Raptors had was basically they were monitoring players and how fast they cut through the baseline, and if they saw some change in their in their velocity, they were identifying that this player must be tired, so they were substituting players. There are other companies, for example, Yinscam, which is actually a local company here in Pittsburgh, but provides services to all the NBA and the NFL teams for fan engagement. So it provides tools like social media, analytics, and other tools such as virtual reality that help engage fans better. Fans both when they are in stadium, but also outside the stadium. So as I said, sports franchises are businesses, and what they want is their customers, which is their fans, to be satisfied and have the best experience they can. So here's another example of this ghosting application, actually from Disney Research. You might be wondering why Disney is into sports. It's actually because they own ESPN, which is a major sports network in the US and maybe worldwide. So what they did here in this work is that they analyzed soccer possessions. I believe it's from Premier League, and basically they were able to build some sort of a probability model on what's the probability a possession will end up in a goal. So for example, in this one that I showed you, which is taken from their work, the scoring probability of this case is 70%, right? Now, what they did is that they built this ghosting system where basically these transparent circles are ghosts, are not real players, but are where the players should have been, right? So for example, this player number 5 is pretty much where he should have been, but this player number 8 is not where he should have been. So essentially, if the defense had played exactly how they were supposed to do, the scoring chance would have been much lower, 41%. So essentially, what this analysis is doing, which uses a vast amount of data, big data, optical tracking from all the games in a season, and uses some deep learning techniques, they are able to put some value on the defensive play of players. So this is actually revolutionizing the way players are evaluated. And the reason is, until now, without the use of this data, we were only able to evaluate the offensive strategy of players, right? In basketball, we were talking about points and rebounds. In soccer, we're talking about goals. But now we have an ability to actually evaluate the defense that the player produces. Okay, so now that we have done this overview of the applications, let's see the last part of this presentation, which is the big failures, right? So not all is rosy in the landscape of big data. There are also failures on applying big data to problems, and in these cases, the failures can be big, right? So for example, traditional statistical techniques that are known for years to have flows, like the p-values, have these flows pronounced when applied on big data, right? So for example, p-values is a concept that we learn during our first statistics course. What p-values can do is that they can identify significance when there is not. So researchers have tried to point out these shortcomings, but the problems keep appearing all the time. So for example, this paper, this research from people at Arizona University of Arizona, Maryland, and Indian School of Business has basically shown that if you have a large amount of data and you try to identify correlations or differences between two data sets, and if you only rely on this statistical concept of p-value, you will always identify a significant effect, because the amount of data is so big that basically we'll always be able to pick up some difference. So in order to see this and understand why this is a problem, let's see an example from the criminal justice system. So let's assume that you are doing a murder investigation, right? And in the criminal scene, you found a fingerprint, right? So typically, what you are doing, what the authorities are doing, is that you are taking this fingerprint and you are passing it through a database with several hundreds millions of entries. So for example, let's say 150 million of entries of fingerprints, and you're trying to find a match, right? You're trying to see whether this fingerprint is in the database, and hence you can identify who it belongs to. Now, the false positive rate is very low, right? Is, let's say, 10 to the minus 8. So you are only going to identify, to falsely identify a fingerprint once in 10 to the 8. Almost once in 1 million. And let's say that you had the match, right? So you pass this fingerprint that you find in the criminal, in the crime scene, you pass it through the database and you found a matching, right? Should you convict this person, right? I hope you won't, because one of the things is that if you go through this big database blindly, right, you expect to find 1.5 matches. So if the person doesn't exist in the database, you still have this false positive rate. But it's very small, but once you have a very, very large database, you are almost guaranteed that you will find a match by a false positive. So this is similar to what we are talking about p-values, right? Finding impact and effect when there is not. Obviously, there are ways to solve around that issue, but these ways are still being developed, right? But you have, so this is one example on why you need to be careful with big data. And possibly, my personal opinion is that here we need to have a fourth V, right? So we talked about the 3 V's of velocity, volume, and variety. We need to have one more V, which is variance, right? The higher the data set that you have, the less variance that you might have for a statistical test to pick up differences. Now, another big flaw in our current thinking of big data is that we keep the human element out of the loop. So everything in big data is just rows and columns or connections or bits and bytes, and we never consider the implications of using this data or how they're being generated. This creates several ethics issues, but also validity issues for the systems built. So one such story is Google Flu Predictor. So you might recall from, you might be aware actually that Google built a system that supposedly was able to predict the flu earlier than traditional methods. And the way they did that is by using queries that they were sent to Google search engine. So for example, if people were looking for the flu a lot, essentially Google said that a flu is coming, a flu epidemic is coming. That was a great example of using big data, but unfortunately didn't work quite as well as it seemed. So the main problem with the method was that the search engine itself was prompting users to search for similar keywords that they had searched for. So if you have noticed, I'm sure many of you have noticed, when you're looking for a keyword for a term, when you're searching for a term in Google, a search engine or in any other search engine, you also get some recommendations. How about searching for this term, right? So if you search for flu, Google will prompt you to search for flu shots and other similar terms. So clearly, this last one should not be counted towards the flu prediction algorithm since it was artificially created by the system. However, what researchers found is that it was counted. This led to overestimation and eventually failure of the application. So the article that you see here basically has way more technical details, but I gave you the layman's description of this. So essentially, when considering analyzing data, big data, the mechanisms through which the data themselves were created need to be considered, right? And in this case, the data were not only created by the people searching something on Google, but also from the algorithm of Google itself. Now, the corporate smart city rhetoric also is about efficiency, right? Predictability, security, safety. You will go to work on time. There will be no queue. You are safe because there are CCTV cameras around you. All of these things make a city acceptable. Certainly, it makes acceptable to live in, but they don't make it great, right? So we have the technical solutions, but what's the problem? We need to think more about fundamental urban problems, what makes people happier, right? At the end of the day, we care about people enjoying living in cities. So as I mentioned earlier, this Good City Life project is a project from these researchers I mentioned earlier, where they are using social media data to map emotional layers of cities. Now, the biggest concern of all has to do with biases. So algorithms don't necessarily lead us to truth. And in fact, they're quite subjective, and they have to do essentially with what data are being used. So the saying goes that big data is algorithmic, so it must be objective and not biased, which is wrong, actually. So all traditional livings of social discrimination exhibit themselves in the big data ecosystem. And what do I mean with that? I mean essentially that once you have an algorithm, what the algorithm will give you obviously is not biased, but how you created the algorithm and how you trained the algorithm, the data that you use for the algorithm can be biased. So, for example, recently Amazon came under fire for algorithmic models that limited its prime delivery service in minority neighborhoods. In both US and UK, financial institutions have been penalized for computer-generated decisions that eventually discriminate against credit or insurance seekers by race. Right. So this race feature used is very discriminative. So the White House actually released a report which found that big data analytics have the potential to eclipse long-studied civil rights protections on how personal information is used. However, the effects are hard to track because we do not have a good understanding of big data. Now, a very interesting book and text on this big data and big risks is this book from Cathy O'Neill, Weapons of Mass Destruction, which basically describes on how algorithms can be biased. So what we basically need in order to solve this problem is policy. So we need new policies on how data are being collected, how data are being used, how data are being used to train algorithms. We need to get education on ethics on data, and eventually we need to have human involvement, right? So at the end of the day, whatever we are doing with big data is done in order to help humans in specific applications, right, in specific domains. So this human element needs to be there in the design from the beginning, on what data you're collecting, how you're using them, how you're training your algorithms. So one very interesting article from Nature essentially says that we need to have more accountability for big data algorithms. And essentially what it says that it's bias in, bias out, by rephrasing the word garbage in, garbage out, which basically means that if your data, your input data, your training data are biased, so is your output. Actually, Gartner says that by 2018, half of business ethics violations will occur through improper use of big data analytics. And this is a big problem because as engineers and as computer scientists, what we are trained is how do you solve all these technical challenges, right? How do you store the data? How do you process the data? How do you analyze them? How do you visualize them? So all of these are clear challenges, but one of the main challenges that many times you forget is the ethics on using this big data. And I hope that if there is only one thing that you get out of today's seminar is this thing, that basically we need to put human into the loop when we're analyzing big data, and we need to consider ethics and biases a lot when we are building a system and algorithms using big data. So, as I said, if you have any questions on what I discussed, you can either send it to George and he can forward it to me, or you can send it to me through the email I have in the beginning of the presentation. And I'm really glad I gave this seminar, and I hope you also enjoyed it. So I'll turn now to George.